This In the Clinic video will task you with answering the following questions. First, how does the gut microbiome contribute to our metabolism? Second, what catabolic pathways do bacteria of the gut use? And finally, what are the clinical features of irritable bowel syndrome, IBS? In your role as a nurse researcher, you are working with gastroenterologists on the impact of various foods on intestinal gas. You observe that diets high in broccoli, beans, and eggs produce increased levels of intestinal gases. What is the origin of these gases, and what is their significance? The digestive system contains multiple organs working together to digest foods. Although many of the structures pictured are familiar, one is often forgotten: the gut microbiome. The gut of a healthy adult is populated with more than 1,000 bacterial species that assist digestion in many ways, including breaking down dietary compounds that our own enzymes cannot digest. Two examples of indigestible dietary compounds found in beans and broccoli are the oligosaccharides raffinose and stachyose. After passing through the stomach and small intestine undigested, these compounds are hydrolyzed by bacteria in the large intestine. The resulting sugars serve as fermentable substrates for the anaerobes that populate the gut. These sugars first enter glycolysis, when they are catabolized to produce pyruvate and the energy intermediates ATP and NADH. The low level of oxygen in the gut means that the gut microbiota rely on fermentation rather than aerobic respiration. Fermentation uses pyruvate as an organic electron acceptor to regenerate NAD+ for another round of glycolysis. This allows gut anaerobes to continue to produce ATP in the absence of oxygen. Different gut microbes reduce pyruvate to different end products, including lactic acid, short-chain fatty acids, and ethanol. A number of gases, such as carbon dioxide, hydrogen gas, and methane, are also generated in the process of fermentation. Therefore, consuming foods high in raffinose, like beans and broccoli, may result in the accumulation of intestinal gases as a result of fermentation by the gut microbiome. The amino acids of proteins also serve as metabolic substrates for gut bacteria, feeding into multiple points along cellular respiration. In one such pathway, the sulfur-containing amino acids cysteine and methionine are converted to pyruvate. In the process, hydrogen sulfide gas is generated, which is why consumption of methionine and cysteine-rich eggs may result in foul-smelling flatulence. What is the fate of these intestinal gases? They are removed from the body through feces, flatulence, or exhalation. For most people, the production and excretion of these gases is a non-event. However, other people face more serious consequences. Individuals suffering from IBS are more sensitive to the accumulation of gases in the colon and less able to rid themselves of these gases. Symptoms of IBS include abdominal cramping, bloating, excess gas, diarrhea and/or constipation, and mucus in the stool. While there is no definitive cure, managing one's diet is often an effective strategy. Avoiding high FODMAP, FODMAP foods is highly recommended. FODMAP contain carbohydrates such as raffinose that may not be easily digested or absorbed. As you've learned, bacteria in the large intestine ferment these indigestible carbohydrates, producing large amounts of gases, which exacerbate IBS signs and symptoms. Finding alternative low FODMAP options is often an effective approach in managing the disease. In this video, we addressed 3 major learning objectives. Remember to always apply your knowledge of microbiology in the clinic.